Let's do some more examples of simplifying complex fractions. So I'm only going to use the LCD method. So we're going to multiply top and bottom by the least common denominator of every fraction in the example. So in this case, the denominators I see are y and y squared. So that makes the LCD y squared. So I'm going to be multiplying by y squared over 1 over y squared over 1 to each term. So all four of them. All right, so if it helps, we're distributing like that. Let's see what we get. So I think I'm gonna write these out where this first fraction becomes y squared over y. The second fraction becomes 3y squared over y squared. Eventually you might not need this step, but it never hurts to show more work. And then 1 times y squared is just y squared. All right, so I distributed that least common denominator of y squared to all 4 terms, all 4 pieces being added, and now all the fractions should cancel. Y squared divided by y is just y. Here the y squareds reduce, so the top of the fraction simplifies to just y plus 3. Already tons better than what we started with. In the bottom, this y squared divided by y is going to give us 3y plus y squared. Let's see that. Now, we always want to factor particularly the denominator. So the denominator, y plus 3 is still on the top. I can factor out a common factor of y. And when I do, what's left is 3 plus y. And 3 plus y is the same as y plus 3, so those reduce. Remember, when everything in the top reduces, you still have a 1 there. So after all that, this ugly fraction we started with really is just equivalent to 1 divided by y, with some domain restrictions though. So if we look at the original problem, the domain restrictions were that y can't be 0, but that's still in the problem that we have. So y can't be 0 is already stated because 1 over y is the simplified form. But we have to look at what canceled in our work. Here, a y equals 0 canceled, that's fine. But this y plus 3 canceling means that our restricted domain is that y cannot equal negative 3. Right? Because that would make y plus 3 in the bottom of this fraction equal to 0. So when we type this answer into WebWork, it'd be 1 divided by y, comma, and then you do the exclamation point equals for cannot equal. Nice. All right, let's try this next one. So first step, least common denominator. So what I'm going to multiply top and bottom by is both the x minus 1 and the x minus 2. Both factors that I see in the bottom of these fractions. And then the 4 doesn't have a denominator, so we're not worried about that. So we're going to distribute both of these pieces to every term in the top and the bottom of the fraction. All right, and I'm going to maybe skip, I don't know, I'm not really skipping a step, but hopefully explaining it in a way that works. So when I distribute both of these factors to the first fraction, the y minus, or the x minus 1s are going to cancel. So what I have left is 2 times x minus 2. All right, the x minus 1s cancel. But here, the 4 is not going to cancel. So it's still x minus 1 times x minus 2. There's nothing to cancel on that one. In the bottom, when I multiply these two factors by 1 over x minus 1, the x minus 1s cancel. So I get just 1 times x minus 2. And then in the second fraction, the x minus 2s cancel. So I get plus 1 times x minus 1. All right, so we got rid of all the fractions. That was the point of multiplying top and bottom by the least common denominator, is so that now it's just polynomial divided by polynomial. We just have to do a bunch of simplifying. First thing I'm going to do to simplify is multiply this piece out, because this is a FOIL. So it's going to be x squared minus 2x minus 1x minus 3x times -1 times -2 is plus 2. And actually, let me put the -4 in front of it too, because that looks like it's a little complicated. So -4 times x squared minus 3x plus 2. Just sort of doing that FOIL ahead of time and making sure now the -4 is going to have to distribute inside of all that. All right, by writing that off to the side, I think will save us a little work here. But still a lot of distributing. So the 2 times x minus 2 makes 2x minus 4. And then I'm going to distribute the -4 times x squared is -4x squared. -4 times -3x is positive 12x. -4 times 2 is minus 8. And in the bottom, this ends up just being x minus 2 plus x minus 1. So the denominator is just 2x minus 3. Not so bad. But the top, we got to combine like terms. So I got -4x squared. That's the only x squared term. Then 2x and 12x make plus 14x. And then -4 and -8 make minus 12. A little bit ugly there. All right. So what I'm concerned with is, does the 2x minus 3, is that a factor in the numerator, and could that cancel? So we really need to try to factor the numerator and see if 2x minus 3 can cancel with it. So let's try that. First, I'm going to factor out the GCF and factor out a negative to make that leading coefficient positive. So it'll be, after I factor out a -2, I get positive 2x squared minus 7x, because it's going to flip the signs. And then -12 divided by -2 makes plus 6 over 2x minus 3. This is an AC method problem. So I need to multiply to a times c, 2 times 6 equals 12, and add to -7, that b. So what could multiply to 12 and add to -7? I think it's -3 and -4. So I'm going to do this as maybe just off to the side here. Because remember, with AC method, you have to, I decided it was -3 and -4, didn't I? I'll do the -3 first, since I said it first. So -3x minus 4x plus 6. You have to split that middle term after you find the two numbers that would multiply to 12 and add to -7. And now we do factoring by grouping. So the only common factor here is an x times 2x minus 3. And in the second two, I'm going to factor out a -2. And then what's left is 2x minus 3. And in factoring by grouping, we're always looking for those parentheses to match. So what I got is 2x minus 3 times x minus 2. And look, my inclination that we might have a factor cancel totally happened. So -2 times 2x minus 3 times x minus 2 over 2x minus 3. Factor cancels. So final answer is -2 times x minus 2 with domain restrictions. So let's go back up, and we got a bunch of domain restrictions on this one. We gotta go back up all to the top, and I can't have x equal 1. I can't have x equals 2. So let's start with those. So x cannot equal 1, 2, and then I canceled here. So that would be 3 over 2. So remember, it's really like setting 2x minus 3 equal to 0. So 2x is 3, or x is 3 over 2. So there are 3 different domain restrictions that we need to put on there, because otherwise the original fraction isn't exactly the same as what we ended with. It's equal to this expression with these additional caveats, or domain restrictions. Okay. Let's try a couple that look a little different, because at first glance, these might not look like complex fractions because I don't maybe see a fraction inside of another fraction. But negative exponents are fractions. So what I'm going to do with this first one is right away write these negative exponents as fractions. So that'll help me see how I need to simplify this. So 2 to the negative third power is 1 over 2 cubed. 2 to the negative 4 is 1 over 2 to the fourth. Same with this, 2 to the negative fourth, and then 1 is just 1. There was no negative exponent on that one. So common denominator is going to be 2 to the fourth that I need to multiply top and bottom by. So in this first one, 2 to the fourth divided by 2 cubed is just 2. 2 to the fourth divided by 2 to the fourth is just 1, but it's going to be a minus 1. Right, the 2 to the fourths cancel, we just get left with the 1 on top. On the bottom, 2 to the fourth times 1 over 2 to the fourth is just 1. And then plus 2 to the fourth. So hopefully we're seeing that here, like all but one of the 2's canceled, but in the 2 to the fourth, they all cancel. No more fractions. I just need to remember what 2 to the fourth is. It's like 4 times 4. So it'd be 1 plus 16. So our answer is 1/17. This one doesn't have any variables in it, so we don't need to have a domain restriction because there weren't any x's to worry about. Let's do one where there's negative exponents and possibly domain restrictions. So again, first step, I'm going to write the negative exponents as fractions. So y to the negative 1 is 1 over y, and then y minus 1 over y. So negative exponents are the same as fractions, so first step is just write them as fractions. So what I need to multiply by is that least common denominator of y. We're going to distribute to every term in the top and the bottom. So in the top, I get y plus 1, y times 1. These y's cancel. In the bottom, it's y squared, y times y, minus 1. And then we look to see if there's any other simplification we can do. And this denominator factors. It's a difference of 2 squares. So the bottom's y minus 1 times y plus 1, which makes the y plus 1's reduce. If everything in the top reduces, what we have left with up there is a 1. So 1 over y minus 1 is our answer. And then we look to see what's not okay to have. In this original problem, I cannot have y be 0. Because remember, those negative 1's are like 1 over y. Also, we reduced here, so y cannot equal negative 1. Another thing I want to remind us that when you're typing into the computer, if you're using web work, you're going to need to use parentheses anytime you have more than one piece in the top or bottom. So you'd be typing this 1 divided by parentheses, y minus 1 comma y does not equal, oops, I need to put an equals, does not equal 0 comma y does not equal negative 1.